All right, so let's just run through a test, how about? Okay, so how do we do stuff like this? If we've got this, we want to do a quotient, we want to simplify this expression involving complex numbers. Okay, so we're just going to, let me make this a little bigger, how about so you can see it. So we've got negative 3 plus 1 plus 4i over 4 plus 4i minus negative 2i. So what do we do? Yeah, simplify the top, simplify the bottom. On the top, if I combine like terms, what do I get? Okay, so negative 3 plus 1 is negative 2, and I only have one I term. Remember, we treat the I like a variable, right? We're just going to add up like terms. So plus 4i on the bottom. So I'm going to get 4 plus 4i minus negative means plus 2i. Right, so that's just going to give me a 4, and then I can combine my I terms. 4i plus 2i plus 6i. Okay? Now, what's our trick for dividing complex numbers? What do we always do? Remember? Well, okay, right, and the way we do that, we can't leave an I on the bottom, but the way we do that is we multiply the top and bottom by the complex conjugate of the bottom, right? So we're going to multiply. What is the complex conjugate of the bottom here? What do we mean by that? What's conjugate? Yeah, good. So it's going to be the same two terms, but change this sign. Instead of 4 plus 6i, it'd be 4 minus 6i. It's the opposite operation, right? We're going to do that to both the top and the bottom, right? And if we do that, what do we get? Well, when we FOIL this out, on the top, if we FOIL this out, first times first gives us negative 8, right? Outside product is negative times negative is positive, so plus 12i. Inside 4i times 4i is positive 16i. And the last, I get 4i times negative 6i. Well, that's negative 24i squared. Right? Okay, on the bottom. Now remember, on the bottom, we can FOIL the whole thing out. It's fine. You can do that. And you're going to get the right answer, but we can take a shortcut. We know that whenever we multiply complex conjugates, we always get a squared plus b squared. Every time. So we know this is just going to be 4 squared plus, it's going to be 4 squared minus 36i squared. But what's I squared equal to? What's I squared equal to? Negative 1, right? Okay. So that makes that a plus, doesn't it, up here? On the bottom, it does the same thing. Instead of a minus 36i squared, we're going to get a plus 36, right? 4 squared plus, I should write that as 6 squared. How about? A is 4, B is 6, right? Because on the bottom it's A plus BI and A minus BI. Okay? Make sense? So then what do we end up with? Well, if we add up like terms, I'm going to get negative 8 plus 24 is, what is that? 16? 12i plus, is that right? Yeah, 12i plus 16i is 28i. So that's what I get on the top. On the bottom, I get 16 plus 36 is 52. So that's my answer. I could just reduce that a little bit, couldn't I? That's really my answer. I could just divide, all those are even numbers, so I could divide the top and the bottom each by 2 and get what? On the top, I'd get 8 plus 14i. On the bottom, I'd get 26. I could divide those by 2 again, right? And get, what's my final answer going to be? I'm going to get, yeah, so I'm going to get 4 plus 7i over 13. just reduce the fractions. Okay, make sense? So that's that guy. The trick, the part you gotta remember is multiplying top and bottom by the complex conjugate. That's how you divide complex numbers. Okay, what about this? Write the quadratic function in general form for the parabola that's passing through these points. Okay, so we want to go general form, right? But we're not going to start in general form. What form do those points match? Factored form or intercepts form, right? And you absolutely have to know these. If you don't know these, go back and memorize them. Go back and learn them. You know, look at your book. This is section 5. No, section, what is this? Yeah, section 5.1 or section 5.8. They both talk about that, either one. So, general form, y equals a times x minus p times x minus q. Or what are p and q in that form? The zeros, right, or the x-intercepts. So that because we have these y values that are 0, those are the x-intercepts, or the zeros, aren't they? So this is just p. P is -3 and q is 5. So we get, if I plug these values in, I get y equals x minus -3 times x minus 5. Well, we're 2/3 of the way there, right? If we just knew what a was, we could just FOIL all this out and distribute and get our answer in general form. We just need to know what a is. Now, how do we do that? X and y, good. Well, here's a value of x and y. So -11 goes in for my x's. -128 goes in for y. And if we do that, what do we get? Let's see. -128 equals a times -11 plus 3 times -11 minus 5. Well, what is -11 plus 3? -8. What's -11 minus 5? Yeah, -16. -8 times -16 is going to be positive 128. Okay, so I get -128 equals positive, what's a times positive 128? So what's a? Yeah, everybody see that? If I just divide both sides by 128, right? If I just do that, I get a equals -1. So I'm done essentially. All I have to do is plug -1 in up there. And that's going to give me the expression y equals negative x plus 3 times x minus 5. That's correct, but we want it in general form. So what's the last thing to do? Yeah, FOIL it out and then distribute to -1. Well, if I FOIL this out, what do I get? First times first, x squared, outside, minus 5x, inside, plus 3x, last, -15, right? And so that equals negative, if I just combine my like terms, I get negative x squared minus 2x minus 15. But I still haven't distributed that minus. What happens when I distribute the minus all the way through? Yeah, I'm just going to change all the signs, aren't I? If I multiply something by -1, I'm just changing its sign. So my final answer just looks like negative x squared plus 2x plus 15. Done. How could I check? See if I got it right, which you're not doing and you should be doing. How can I check to see if I get it right? Plug in those points and see if they work. If I plug in -3 for x, I better get back 0 for y. If I do, check. If I really want to be sure, I'll plug them all in and see that they work. Just plug them in on my calculator, right? That's a way I can know if I get it right. Okay, very, very, very simple. Just read these questions though. Remember, if they're asking for, what does this mean if it asks for that? It's telling us that z equals -9 plus 6i. What does this thing mean? What is it again? Absolute value is one way to think of it, kind of, and that's what the book calls it, or the modulus, right? Remember what that is for a real number. It's just, you know what it is. It just means absolute value. But it's not. It's a complex number with an I value, right? And so remember, what's the formula for modulus then? That's it. Yeah, all it is just the square root of a squared plus b squared. The only place you could screw this up is if you didn't correctly identify what a and b are. Well, what's a? -9. What's b? Is it 6i or 6? You're right. It's just 6, right? Because this is a complex number we always write as a plus b times I. B is the coefficient of I,
just
right?
a reminder, check your email for the list of students that are to be sent after 10 o'clock for testing to room 203.
Okay, so then all we have to do is put in the square root of -9 squared. What do we do when we square a negative though? Square the positive. So we do 9 squared plus 6 squared is what? 81 plus the square root of 81 plus 36. So that's the square root of 117. That is your answer. Okay? Make sense? Does 9 go into that? I think it does, actually. This happens to be one, this is kind of a tricky one. I think that would reduce. I think that's, 117 is just 9 times 13. So we could write that as 3 times the square root of 13. Okay? All right, we'll pick it up later, tomorrow.